Okay, so now that we've finished up our data unit, we're going to be looking at stats. So first we're looking at measures of central tendency. So our measures of central tendency are our mean, median, and mode. Okay, so the first definition here, the average, adding up all the values and dividing by the number of values in the data set. So think to yourself, is this mean, median, or mode? So the average is our mean. Okay. The next definition, the value that lies in the middle of an ordered list. Okay, so this is putting the numbers from lowest to highest and then finding the middle number. That number is our median. Okay, so to find a median, if there's an odd number of points, it is the middle number. If there's an even amount, then there's two numbers that we need to find the average of, meaning we would add those two middle numbers together and divide by 2. And the last one, the value that occurs most frequently. So that is our mode. The 14 students in Jesse's math class measured their heights to the nearest centimeter. So determine the measures of central tendency for this set of data. That means we want to find the mean, median, and mode of the data set here. The first thing you always need to do is put the numbers from lowest to highest. Okay, so I'm going to do that now. As I go up, I'm just going to cross them off to make sure that I get them all. Okay. So it tells us that there's 14 students, so we want to double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have all the numbers there. Okay, so finding the mean, we are adding up all the numbers and then dividing by the number of numbers, which is 14. So when we add all of these up, we get 2,371. We divide that by 14, and our mean is 169. Okay. Our mode is our most common. And if we look, the only duplicate number we have is 167. There's 2 of those, so that is our mode. Now, our median. Since there are 14 numbers, there's an even amount. There's going to be 2 middle numbers. So that's at position 7 and 8. 1, 2, 3, 4, 5, 6, 7. So at 7 and 8, that's the 167 and the 168. So we add those and divide by 2, and that's our median. So we have 167.5 as the median. Okay. What percent of the class is shorter than each measure of central tendency? So if we look at the mean, our mean is 169, and we want to count the number of students below 169. So that's 1, 2, 3, 4, 5, 6, 7, 8. That is 8 out of 14 students that are shorter than the mean. So 8 divided by 14 times 100 gives us our percent, and that is 57%. Now for our median, we are looking at the students that are shorter than 167.5. Okay, so that's starting here, 1, 2, 3, 4, 5, 6, 7. So 7 divided by 14 times 100, and that's 50%. And the last, which ones are shorter than the mode? The mode being 167. Shorter than that is starting with the 165. So 1, 2, 3, 4, 5 students. So 5 divided by 14 times 100 gives us 36% of the students. Okay, so Ryan is taller than 65% of the class. How many students are shorter than he is? What is Ryan's height? So if we have 14 students, and we know that Ryan is taller than 65% of those, that is multiplying by 65 divided by 100. So 14 times 0.65 gives us 9.1, which means that Ryan is taller than 9 people. Okay. Because Ryan is taller than 9 people, that means he is the 10th tallest person. So we would count up to our position 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means Ryan is 176 centimeters tall. Okay. So that's how we're calculating our measures of central tendency, and then looking at certain percentages within our data. Okay, so mean, median, and mode are used to describe central values or typical values for data. We can also measure how spread out the data is using range, variance, and standard deviation. So our range is the difference between the greatest and least value in the data. So when you're calculating range, this is the highest number, subtract the lowest number. Okay. When we talk about standard deviation, this is the typical distance of a particular value from the mean. So in order to calculate this, we need to know what the mean is, and we are going to subtract the mean from each data value. Once we do this, we square each difference and add the squared numbers. We then divide this sum by the number of data values and take the square root. Okay. The lower the standard deviation, the more consistent or less spread out the data is. And if we want to find variance, The variance is the mean of the squares of the deviations from the mean for a set of data. So it's the answer after the first 5 steps listed above. Okay, so the variance is before you take the square root. Okay, so it's the answer before square rooting it. That's the variance. Okay, so we technically calculate variance before we can calculate standard deviation, because we need to take the square root of the variance. Okay, so we're going to be looking at all these different values based on this question here. So Moby and Toby are 2 twin basketball players. Points are recorded below for the 2 basketball players. Okay, compare these 2 players by calculating their mean, median, and mode. So the first thing you want to do is arrange the data from lowest to highest. Okay, so for Toby, 10, 13, 14, 15, 15, 16, 17, and then 20. And our names don't match up here. Let's change this one to Mitch. Okay, so for Mitch, we're going to order these. So 6, 10, 11, 12, 18, 19, 20, 24. Okay, so if we first do Toby's calculations, the mean, we're adding up all the numbers. So 10 plus 13 plus 14 plus 15 plus 16 plus 17 plus 20 divided by our number of numbers. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so adding all those up, and dividing by 8, we get 15. If we then look at the median, because there are 8 numbers, we need to look at the middle 2, so position 4 and 5. So those numbers are 15 and 15. 15 plus 15 divided by 2 is 15. So our median is 15. And our mode, being our most common, there is a duplicate of the 15s and no other number, so our mode is 15. Okay, so now let's calculate for Mitch. Again, the mean, we are adding up all the numbers and then dividing by 8. There are 8 numbers. So 6 plus 10 plus 11 plus 12 plus 18 plus 19 plus 20 plus 24 divided by 8. That's giving us an answer of 15. Looking at the median, there are 8 numbers. Positions 4 and 5 is 12 and 18. So 12 plus 18 divided by 2 gives us a median of 15. And our mode, our most common. We do not have any duplicates. There's only one of every single number. And because there are no duplicates at all, there's only singular numbers, there is no mode. Okay. There are scenarios when you can have So this is a scenario where there's no mode. With Toby, we have one mode. We can also have more than one mode. So if there were two numbers that are doubles, both of those numbers would be the mode. Okay, so it is next asking us what the range is. So if we look for Toby, we want to use the highest number, subtract the lowest number. So that is 20 minus 10. So that gives us a range of 10. Now, if we look at Mitch, the highest is 24, the lowest is 6. So 24 minus 6 gives us 18. Okay, and what does the range tell us about these players? Okay, so the lower the range, the closer the numbers are. So with Toby having a lower range of 10, we can say that Toby is more consistent. Okay, so the next thing we want to do is we want to find our variance and standard deviation for the basketball players. So we first are doing the data. Okay, so these are the number of baskets that they, or the number of points that Toby has. To calculate our variance and standard deviation, the first thing we need to do is take the data value, which is these ones, and subtract the mean. So for Toby, our mean is 15. So 13 minus 15 gives us a negative 2. 17 minus 15 is 2. 20 minus 15, 5. 10 minus 15, negative 5. 15 minus 15, 0. Same thing again. 16 minus 15 is 1. And 14 minus 15 is negative 1. Okay. So once we have these differences, we want to square those differences. So negative 2 squared is 4. 2 squared is 4. 5 squared, 25. Negative 5 squared, 25. 0 squared is 0. 0. 1 squared is 1. Negative 1 squared is 1. Okay. And now we need to add up all of the square of the differences. So 4 plus 4 plus 25 plus 25 plus 0 plus 0 plus 1 gives us a total of 60. Okay. The last step for our variance, once we have the sum, we need to divide by the number of numbers. So there are 1, 2, 3, 4, 5, 6, 7, 8. So that is 60 divided by 8. And we get 7.5 as the variance. And standard deviation, that's taking the square root of the variance. Okay, so the square root of 7.5. So our standard deviation is equal to 2.7. Okay. Now let's look for Mitch. For Mitch, let's recall what the mean is. The mean for Mitch is also 15. So let's go and calculate. Okay, we have the number of points, and we're going to subtract the mean. So 20 minus 15 is 5. 11 minus 15, negative 4. 6 minus 15, negative 9. 24 minus 15 is 9. 18 minus 15 is 3. 12 minus 15 is negative 3. 10 minus 15, negative 5. And 19 minus 15 is 4. Once you have your differences, you're going to square all those differences. So 5 squared is 25, negative 4 squared is 16, negative 9 squared is 81, 9 squared, 81, 3 squared is 9, negative 3 squared, also 9, negative 5 squared is 25, and 4 squared is 16. We then add up all of the square of the differences. So 25 plus 16 plus 81 plus 81 plus 9 plus 9 plus 25 plus 16. That gives us 262. Okay. Our variance is taking that sum, 262, dividing by the number of numbers, which is 8. So 262 divided by 8 gives us 32.75. So again, our standard deviation is the square root of the variance. So finding the square root of 32.75, and that is 5.72. Okay. So looking at the standard deviation for Toby and Mitch, for Toby, it was 2.7, and for Mitch, it's 5.72. Okay, so that's saying how far apart our data is. So the smaller the standard deviation, the more accurate that it is. So that, again, is telling us that Toby is more consistent. So that means Toby being more consistent means he gets around the same points every single game, where Mitch, the amount of points that he gets can vary more widely. So looking at percentiles and quartiles. So percentiles tells what percent of the data are below a particular data value. Okay. So if we have n% of the data are less than or equal to the nth percentile. Okay. And if we're looking at quartiles, this is when we divide a set of ordered data, meaning lowest to highest, dividing it into 4 equal parts. Now, the second quartile, Q2, is the median, so the middle number of the data. it cuts the data set in half. So it has the same as the 50th percentile. The first quartile, Q1, is the median of the first half of the data. So going from the lowest number to the median, if we cut that in half, that is our Q1. Okay, so this is below our Q2. It divides the lower half of the data set in half. So it is the same as the 25th percentile. And the third quartile, Q3, is the median of the second half. Okay, so that's dividing in half from the median of the data to the highest number. So it divides the higher half of the data. This is also saying the same as the 75th percentile. So if we are dividing this, this here is our lowest value. And at the other end, we have our highest value. Okay. Now, when we cut this data in half, that halfway mark is our Q2, which is also our median. So, like we said, with our first quartile, that's going from the lowest value to the median, and we're cutting that first lower piece in half. So cutting that first lower piece in half, that is our Q1. And the third quartile is going from the median to the highest value, so cutting this higher piece in half, which will give us our Q3. Okay, so another example. Here are the hourly pay rates in dollars for 17 high school students with part-time jobs. Okay, so looking at this data set, the first thing you need to do is order it from lowest to highest. So I already have that done here below part A, which states what are the quartiles for this data set. Okay, so we know that there are 17 numbers. So because there are 17 numbers, then our halfway point is going to be after 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers that are below that, and 1, 2, 3, 4, 5, 6, 7, 8 numbers that are above it. So the Q2, or the median, is 9.45. Okay, so next, to find our Q1, we need to focus on the first half of the data, and that's these 8 numbers here. Okay, so looking at halfway through that, that's looking at positions 4 and 5. So that's the 8 and the 8.25. So our Q1 is going to be 8 plus 8.25 divided by 2. And that's 8.125. Now our Q3 is looking between the 9.5 and the 13. Again, there's 8 values there. So counting 4 over, 3, 4. We're looking at 10.75 and 11.25. So for our Q3, 10.75 plus 11.25 divided by 2 gives our quartile 3, which is 11. Okay. So Damien's pay is in the 85th percentile for this group. What does percentile mean, and what is Damien's hourly rate, pay rate? Okay. So being the 85th percentile of 17 students, we can say that is 85%, or 85 divided by 100. And we multiply that by the 17 students. Sorry about that. So when we say 0.85 times 17, we get 14.45. So that means that Damien is making more money than 14 other people. So because Damien is making more than 14 other people, that means he is at position 15 in our list of data. So if we count up through our data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's this one here. So that means Damien's hourly rate is $11.50. So when you're given a certain percent, we can turn that into a decimal and multiply it by the number of numbers that there are, and that's going to give you a position for that percentile. Okay. So you are going to be given a worksheet. So work away on the worksheet and let me know if you have any questions. We're going to continue with interpreting statistics tomorrow as well.